So today what I've given you is a great big fat packet of AP problems. Um, there are 10 free response questions and there are 6 multiple choice towards the end. What I would like you to do is, and we'll go over, say, the first one together, but what I'd like you to do is have at least half of the free response done by class time tomorrow and at least half of the multiple choice questions. Okay? So, and I'll give you some time, and we'll do this one together. That'll save you some time as well. All right, so this one, I actually graded this one years ago. So Karen rides her bicycle along a straight road from home to school, starting at home at time t is equal to 0 minutes and arriving at school at time t is equal to 12 minutes. During the time interval from 0 to 12 minutes, her velocity, v of t, in miles per minute is modeled by the piecewise linear function whose graph is shown above. And then we ask all kinds of questions here. So first, find the acceleration of Karen's bike at 7.5 minutes. Indicate units of measure. So from velocity, how are we going to find acceleration? All right, we're going to find the slope because the slope of the velocity, because acceleration is the derivative of velocity, and the derivative is the slope. So the slope, this goes down 0.1 and to the right 1. So it's negative 0.1 over 1. And it is miles per minute per minute. Right, because it's the rate of change of miles per minute. And if you want to write miles per minute squared, that's not a problem. But I think I've preached enough on the fact that I think this explains what's going on better than what miles per, what's a square minute. All right, using the correct units, explain the meaning of the integral from 0 to 12 of the absolute value of v of t dt in terms of Karen's trip. Find the value of that integral. All right, so what is that? That's one you have to have just memorized.
The total distance traveled.
All right, so the integral is the total distance Karen traveled in miles from t is equal to 0 to t is equal to 12 minutes. And now we want to calculate that. So how do we calculate an integral from a graph?
Take the area.
Yeah, take the area, and it's the absolute value. So I'm actually going to go, okay, any part that's below the axis is going to be reflected up. So this is a triangle with an area of 2, plus that's a triangle with an area of 2, plus this triangle is 1.5, and that's 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. I'm just counting the squares from here to here, plus 1. Miles. But what have I done wrong here?
You haven't looked at the y-axis and used the right units.
Yeah, it's 0.1 for every one of these. Okay? And the reason I did this today is I did exactly the same thing the first time I did this problem. Because you're used to everything, every grid being 1. This is actually 0.2, 0.2, not 1.5, but 0.15. I doubt I'm going to be able to erase that. This is going to be 1.15 and 0.1. Right? I had her traveling way too far. I had her traveling 10 times as long. Yeah, well, and especially when you think it's over 12 minutes. And again, on the AP exam, you don't have to simplify that if you don't want to. In fact, as I would suggest that you don't. Shortly after leaving home, Karen realizes she left her calculus homework at home. Oh no. And she returns to get it. At what time did she turn around to go back home? Give a reason for your answer. When did she turn around to go back home?
T equals 2.
Yeah, at t is equal to 2. How do we know that?
Velocity changes sign.
Yeah, specifically from
2 to 4. Positive and negative.
from positive to negative. Just by the way, now that they have that explanation, I'm like, okay, so she was riding away. She realizes at this point, she slows down, turns around, pedals back towards home, slows down. What's happening here?
Resting.
Or she's running up the stairs to get her homework. And now she rides much faster than she did. She gets to her top velocity and goes, okay, I'm going to make it. She slows down a little bit and then coasts into the school. All right. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function w given by w of t is equal to pi over 15 times sine of pi over 12t, where w of t is in miles per hour, or miles per minute, for 0 to 12 minutes. Who lives closer to the school, Karen or Larry? Show the work that leads to your answer. All right. So, how far does Karen live from school?
Answer B. How many miles?
Except she went,
The displacement, yeah.
she went back. So we're going to have to get rid of these two bits, right? So we really only need that last part. And we do need to calculate this time because we need to be able to compare it to something else. So Karen's house to school is 0.15 plus 1.15 plus 0.1. So that's 1.35 miles. And then Larry's distance, or Larry's house to school, is going to be the integral from 0 to 12 of w of t dt. I have no idea what that's going to be. So the integral from 0 to 12 of pi over 15 times sine of pi t over 12 and I got 1.6 miles. So it is Larry. If you gave the answer from part B, this is going to be another point 2 and another point T. It came out to be Karen. And that's part of how they made it easy to grade because as soon as you saw that, you knew what they had done wrong. And, they lost points appropriately, or more specifically, didn't gain points that they would have. Okay, any questions? Okay, then I'm going to give you the rest of class time to just work on that.